starting it.
Alright, get started.
It has been started.
Alright, 7-4. We're gonna. You good?
Yeah.
Alright. 7-4. Yesterday we did 1 and then 2 through 26. We are gonna do a few more today. Will be due tomorrow. Alright, number 27, look at that. The least common denominator of two rational expressions is a product of the two denominators. Always, sometimes, or never. The two rational expressions is a product of the denominators. Did you guys, anybody do it? Did anybody do the math?
I got to 14.
And so, were you okay on the 9 through 15? Do you want me to go back over those and teach those better in a different way?
The only thing I didn't get 14 or 16. I didn't understand how to do
Don't you
those
just
two.
have to put whatever is what?
I
It
didn't know if I
is.
did 10 and 12 right.
Look at, okay, let's go back over those again. Look at number 15 again, because I did not teach that well yesterday. X squared plus 3x minus 40. We said this factored to,
Plus 8
8
and
and 5.
minus 5.
and then the other term was
X minus 8.
x minus 8.
So it's
Okay, so this is one term, this is another term. Okay, when you're doing the least common multiple of it, anything that's included, you have to include it once. So we have an x plus 8, include it. An x minus 5, include it. An x minus 8, include it. So your answer is all three of those things. So like on 9, when it was 3x, and then 3 times x minus 2, I'm gonna write it down here. The thing we have here is 3 times x. The thing we had here was 3 times x minus 2. Okay, so we had 3 in both of these, so we had to include it once. We have an x, we have to include it, and we had to include the x minus 2. We don't include the 3 twice because we already have it. So this one was 3x, x minus 2. Does that make a little more sense? Okay, and then this one was all 3 of those.
I don't think I did them right.
Okay, I didn't feel like I taught it like in a way that I needed to yesterday.
I'll
Sometimes
have
it's hard when you just see it and you don't know how to verbalize what you're
I'll
trying
have
to
you
say.
check it. And
Okay.
see it a little bit.
All right, does that help on those a little bit? Yep. Okay. All right, what did we decide about 27? The least common denominator of two rational expressions is the product of the denominators. Let's write down 13 and see if that will help you make a decision. So 13 is x squared minus 25. And then what's the other one?
X minus
X
5.
minus
X minus 5. Alright, so this one would have factored here, right? This is a number, this is a number. What would our least common denominator be of those two? We would have to include both of these things. I don't have to include this one twice, right? So it's x plus 5, x minus 5. Alright, so thinking of that, when it says the least common denominator of two rational expressions is the product of the denominators. Okay, well these were our original numbers right here. Is it the product of those two numbers?
No.
It's not, right? Sometimes that's the case, but not always. So this is one of our exceptions where it's not the case. So that answer would have been sometimes. All right, look at number 29. In these they ask us to analyzing equations. How would you begin to rewrite the function to obtain the form? All right, so in our last section, what did we do? We did long division, right?
Yes.
Right? Okay, so how they're showing us to do these is plus 1, that may be too high. What's the denominator?
X plus 2.
Alright, so what they're asking us to do here is, we're rewriting this, we're gonna take that denominator and put it into our x in our numerator. So we would have 4x plus 2. Alright, so we're still needing our numerator to be 4x plus 1. If we're thinking about this multiplied out, we would have 4x plus 8. You see that? But I need it to be 4x plus 1. So what else would I have to have out to the end?
Minus 7.
Minus 7. Alright. Okay, so that goes here. So this is our first step right here. That's one of the options, right? 129, is that one of the options?
Yes. It's
The A. Okay, and I'll work, that's just the first step, we'll finish that. It doesn't take much to finish that problem. Do it. Alright, so 31 is like this. We're just gonna complete it. We have 5x minus 7, x minus 1. Okay, so in 7.3 we did long division. Here we're gonna rewrite, so we have 5 times x minus 1. Okay, and then I have to figure out what else I need out here.
Minus 2.
So we have 5x minus 5 if I distribute, but I need it to be negative 7, so yeah, it would be minus 2. This is just kind of my workout here. This is the next step. All of this is still over that x minus 1. Okay. Everybody good from getting from here to here? Yeah? Okay. Alright, so once we're here, we have 2 terms on the top. We're going to split them up because then we can cancel something. Alright, so I'm going to rewrite this as 5 times x minus 1 over x minus 1 minus 2 over x minus 1.
Okay.
Okay, so we can cancel here.
Couldn't you just divide it?
They're just showing you another way to do it. Yeah, it works if you do division. You're gonna get to the same place. Alright.
Dadgum, Skeeter.
Well, that was something.
Congratulations, you broke it.
But the lights are still on. Hey Sam, why don't you stop that for a minute?
Alright, sure.
I feel like this is the smart board.